Hi everyone. So today I will be discussing Leetcode daily challenge problem 402, remove key digits. So in this problem, uh, string input nums is given and k is given. So what we'll have to return is basically a smallest possible string which we can obtain after removing k characters from this num string. So for this example, if we remove 4, 3 and 2, so we'll obtain 1219, which is the smallest possible number, and but we have to return it in the terms of string. For this case, we can only remove one one letter, so one digit. So here if we remove this one, then we will be left with 0200, which is basically 200. This is the minimum possible. Here in the third example, we can remove both the digits to obtain the minimum possible string which is 0. Now a brute force approach to solve this problem would be to check every case. For example, what we can do is remove this one, remove this one, remove this one. We will obtain 2219. Now we can also try removing this. So we'll obtain 3219. We can try removing this. We'll obtain 3219. Can try removing this. We'll obtain 3229. So on and so forth. So, but in this case, what we'll have to do is try out all possibilities. So then we can take the minimum out of all those possibilities. But the possibilities will be this length 7c3. For this case, it will be 7c3, which is 7 factorial divided by 4 factorial into 3 factorial, which is basically 7 into 6 to 5 divided by 6, which is 35. So we have to check 35 possibilities for this case. But let's say if the string is of 10 raised to power 5 and k is also like, let's say, 10 square or something, then we'll have 10,000 factorial. So we'll have this power 5 factorial divided by 10 raised to power 5 minus 10 square factorial divided by 10 square factorial. This will be a huge number. So the complexity of the solution would give us TLE. So a better approach from this previous one approach would be to basically see minimum number in k plus 1 size window. So what we can do is, let's say for this case 1432219, k plus 1 would be 4. So what we can do is, let's say this window, we'll check the minimum in this window. The minimum is currently 1, so we'll add 1 here. Then we move our window to here. Now here the minimum is 2, so what we'll do is take 2, and now since we have not considered these two, so now k will become 2. Oh sorry, k will become 1. Initially it was 3. Now since we have removed 2, so now this will be 1. So now we will check 1 plus 1, that is 2 size window. Now 2 size window would be uh, this. So now here it is 1, so we'll add 1, and since we have not considered this, so now k would become 0, and then we'll add rest of the elements like 9. If it would have been, let's say, 543, then the answer would be 543. Now the problem with this approach also is that, let's say, the input is 1 2 3 4 5 6 7 and k is, let's say, 3. Now what we will do here is that create a 4 size window and check the minimum. The minimum would be 1. Then again from here we'll check the minimum will be 2. Again from here we'll check minimum would be 3. Again from here we'll check minimum would be 4. So this will be an answer, but for every letter we are checking k times. So now for, let's say, n equals to 10 raised per 5 and k is, let's say, 10 square, then the computational time 10 minus 10 square into 10 square. This would be the computations involved and uh, involved in this case, given that the string is, let's say, um, increasing every time. So in that case this solution would not work. So a better way to solve this problem is to create a variable k plus 1 size window using dq. So if the input is 1432219, and start from here j and I. Now in this dq, until we get to this k plus 8 window, we will add the jth element. So currently the jth element is 1, so we'll add. Now again, now we move our j to 4, so we'll add 4. Now we'll move our j to 3. Now this 4 is greater than 3. Okay, so we don't need this 4, because uh, let's say we choose this one for our answer. Now we move our window from here to here. Now the uh, 4 would obviously not give the answer, because in this 4 size window here the minimum would be 2, so 4 is not giving the answer anyway, so we don't need this 4. So remove this 4 and then move the j to 2. Now j becomes 2. Now again it is this 2 is greater than 3, so again 2 will be added. So now j becomes this. Now this k plus 1 was 4, but now this window is of size 5. So then in that case we'll have to obtain see now we have to check from this dq what is the minimum that we have obtained for this window. The minimum for this window was 1, so we'll add 1 here to the answer and then move the ith element to here. Now now again this thing is again j minus I, which is 0. Now again it is 4 minus 1, which is 3. So what we will have to do is see what is this value in this location. So it now also since we have considered this one as our answer, so now we'll remove this one from here and the cube will have only 2. Now again we see that in this position there is a 2, so we'll add 2. Now move our j to here. Again this j minus I becomes greater than k. So now since it is greater than k, now we'll have to check for this window what is the minimum. The minimum is 2, so we'll add 2 here and remove 2 from here. Now one thing here is that since we have considered this 2 and did not consider these two, that means we have removed these two, so now k becomes 1. And also since we have done the computations till this step, so we'll move our pi directly to here. Now k is 1. We still haven't done this computation for jth element, so we'll do it here. So now 1 is smaller than 2, so now this one will be added here. So for this window 1 is the minimum, so 1 will be added here. Now this again we have not considered this 2, so that means we have removed this 2, so we'll set our k to 0. Now k becomes 0, so we'll directly add 9 here, so this will be our answer. So now let me explain this through the code once. So now here I is 0 initially, j is 0, answer is empty, also dq is empty. Now again I what we'll do is for jth element we'll add this to dq will be 1. Now j will be 1, again 4 will be added. So basically here I'm not adding exactly the this corresponding number, but the indices. Now here in this while loop I'm checking if this last element until we find a smaller value from this. Let's say for now this j becomes 2, now the j is 3 and this is 4, so I'm checking until and unless I find a smaller value than 3, I will remove these last elements from this dq. So now this will be removed and 2 will be added here. Now again j is 3, now again this is 2, so this will again be removed and 3 will be added here. Now j becomes 4. Now 4 minus 0 is greater than 3, so now we'll have to move our calculations to this one, this if loop. Now in this if loop I am checking if I is equal to this dq first element. So here I is 0 and this dq first element is also 0, this is denoting the index. So since this is 0, what we'll do is first of all remove this 0 from here, and in the answer we'll add this character present in the 0th index, so it is 1. So now 1 is added here, and now since we have only chosen this 0th index only and did not remove any element as of now, so this k will still be 3. The k is still 3. Now I becomes 1 and j is 4 and k is still 3, so again j minus I is not greater than 3, it is equal to. So again we will do the computation for the jth index. Now jth index is 4, fourth index is this. So now again 2 is not 2 is equal to 2, so now we'll add this fourth index. Now again j becomes 5. Since now j becomes 5, So again j minus I becomes greater than k. So now here, now in this case, the ith index is 1, but the dq first element is 3. So we'll not go in this loop now, we'll go in this loop, and we will add this element corresponding to the third index to the answer. So in the third index we have 2, so we'll add 2 here, and now we'll see how many elements we have removed. So this we have added this element in the answer, and I was here. So we added this element and I was here, so we have removed these two elements, 4 and 3. So what we will do is decrement our k from 3 to 1, and after decrementing our k, we also have to increment our I. So now I would become, since now we have done the computations till this step, so we will increment our I to here and also remove this element from here. So now I becomes 4 and j becomes 5. Now again j minus I is currently 5 minus 4 equals to 1. So and k is also 1. So again this j minus I is still not greater than k. So we will again do the computations for jth index. So the jth index is 5. So since the jth index we have 1, and in this dq we have fourth index, and the value corresponding to this fourth index is 2. So we'll remove this fourth here and add fifth. Now again j becomes 6 and I becomes 4. Now again 6 minus 4 becomes greater than k, because k is now 1. So again now we'll go inside this if statement, and now again this I is 4 and this first element is of dq is 5. So again we'll go in this if loop and not in this one. So now again we'll do the same thing, we'll add the corresponding letter to the fifth index, which is 1, and then remove this 5 to here, and k would become now 0 and I would become 5 and 0 would be 6. And now we will stop the computations because k became 0, and we were running only till k is greater than 0. So now we have 1 to 1, but the answer should have been 1 to 19. So what we will have to do is basically until in this step, until j is smaller than num dot length, I'm just adding this to the answer. So the answer becomes 1 to 19, and here I'm checking for few corner cases. Let's say answer dot length is 0 for this example. So then in that case we don't have to return the empty string, we have to return 0. And here I'm removing this trailing zeros from the answer, and if the answer again becomes 0, then we don't have to return the empty string, we have to return 0 here, and otherwise we'll return the answer. The time complexity of this solution would be O of n, because we are only looping till n, where n is basically length of none. And if I try to submit this, it is getting accepted.